Hi everyone, good morning. Am I audible to all of you? Can you please confirm in the chat? Yes, hi Somit. Hi guys. Okay, thanks for the confirmation. Fine. So let's wait one more minute so that everyone can join and we can start with our session for today. What are your plans for production level agentic AI application? So agentic AI like course is coming. It will start from 15 January. So you can check it out. Free and show. Love from Nepal. Thank you. Kirao Takari. Yeah, good morning, Krishna. Okay, fine. So I think we can start, guys. So I think you remember yesterday I was talking about containerization. We created the custom image when we did the we created the image, then we pushed the image to the like registry hub, even we ran that image as a container. Then I started implementing advanced ML pipeline. Okay. So today we'll try to complete that pipeline we have started. Okay, entire project we'll try to complete, and yeah. So this is the agenda, and next class onward, I will start with the continuous integration and continuous deployment part. So there I will show you how we can use the Docker. We will be using different CI/CD tool, and with the help of that, we'll try to do the deployment. Okay. Then we'll implement some project, whatever tools we have learned, let's say DVCML flow, we'll try to integrate and we'll try to create the entire system. Got it. So let me present my screen. So here, just a minute. Yeah. So can you confirm, guys, if is my screen visible to all of you? Can you see my screen? I hope it is visible to all of you. Hmm. So now what I will do, guys, so I think you remember this is the repository we created yesterday. So let me share the link again. So here I'm going to commit all of the source code. So I'm sharing over the YouTube as well as over the dashboard. Okay. So let's open up my VS Code. So this is the implementation we left. So I think we completed till this one setup part. Even we have written like utility, login functionality, and everything. So first of all, we'll start with the notebook experiment. Okay. So first of all, we'll try to do the entire notebook in entire project on our Jupyter notebook, and then we'll try to see how we can convert it to the modular coding. Okay, this is what we'll try to learn. So for this, in the resource folder, I'm going to create a file. Let me create a file. Resource folder. I'm going to create a file. I'm going to name it as experiment.ipynb. So inside that, we'll just try to write all of the code. Let me select the kernel, ML project. Everything is fine, I think. And here I already kept the data, guys. You can see in the data folder, I already downloaded the data from the Kaggle website, this red wine quality data.csv, and I kept in the data folder. So let me push the data as well in my GitHub. So data added. It's done. Now you can refresh the GitHub page, and from there you can get the data. Okay. Hmm. So first of all, let's load the data. But before that, one thing actually you have to take care. So first of all, let me show you my project working directory. So if I do import operating system. Now if I just write pwd project working directory, you can see I'm inside resource folder. That means this folder. Okay, I'm inside this folder, but my data is present inside data folder. It is outside of the resource folder. Now how we can handle this scenario? So in case actually you have to get back to your root folder. What is the root folder? Root folder means this is your root folder. Okay, and currently we are inside this particular folder, so we have to get back to the root folder. How to get back to the root folder? So inside operating system there is a function called change directory. Okay, inside that you have to mention um, dot dot slash. Dot dot slash means you want to get back one folder. Okay, now see if I execute. Now if I again do the pwd operation, now inside you can see I'm inside my root project folder, which is nothing but end-to-end machine learning pipeline. Okay, so that's how if you want to get back any folder, you can use this particular function change directory, right? Because from the terminal we know that how to do it. So from the, let's say, terminal, we know how to do it. We can write cd dot dot command and with the help of we can do it. But what about for the notebook? Okay, so that is what I told you. So let me activate my environment also here. So this is the environment. Let me activate in the terminal. Fine. Now next thing, let's try to load the data. So for this, I'm going to use the pandas. So I think you already familiar with pandas library. With that of pandas, we can load any kinds of CSV data. Then we can load Excel data, JSON data, any kinds of data we can load, and we can do the manipulation. So pandas SPD. Then I'll define my data path, data underscore path. What is your data? Your data is present inside data folder. Let's copy the relevant path. And here let's mention it should be forward slash. Okay, then after that I will load the data. So this is wine data. I'll name it as wines. pd dot read csv. Inside that, just try to mention the data path. That's it. Now let's load the data. Now if I show you wines dot hit, so guys, you can see this is my data. Okay, so we have the features like fixed acidity, volatile acidity, citric acid, and so on. Based on that, we have to predict the quality of the wine. Okay, this is the problem statement. So again, I told you, see here, my intention is not to show you how to create the good model, but I will show you how we can create the efficient pipeline. Okay, so if you want to train a good model, I think you know how to train a good model. For this, you can perform different feature engineering, export, edit, analysis. Okay, these are the operation you can perform. But here I'm not going to do so many, let's say, feature engineering EDA part. Instead of that, we'll try to train the model directly, and I'll show you the entire pipeline in the next implementation. Okay, I'll show you how we can do the feature engineering EDA part. Okay, that means we'll try to discuss everything in detail. But here, just to show you quickly, because I know that there are so many learner who has joined for the first time, so I'm keeping things as like very simple so that everyone can understand. Okay, at the end. So this is my main intention. Okay, fine. So now if I want to see any information about the data, maybe we can use the info function, which is available in the pandas. So info. So info will show you the entire information, like what kinds of data type of the column. Okay, whether it is having the null value or not, how many, let's say, uh, entities you have, how many columns you have, everything it will show you. And if you want to see the like data, how many record you have, so you can use the shape attribute. So you have 1599 rows and 12 columns only, okay, in this data. Now if you want to see some statistical, let's say, uh, analysis, for this you can use describe function. So describe will describe your data, like what is the mean of the data, what is the standard deviation of the data, what is the minimum value, what is the 25% percentile, 50% percentile, okay, 75% percentile, and as well as the max value. Okay, so you have already learned this thing in your statistics or machine learning, basics of machine learning, I'm expecting, right? Hmm. Okay. Then let's check whether I'm having any missing value or not inside a column. So I can use is null. Okay, and it will give me true false, but I want the count. So for this I'm going to use the sum function. Sum will list down, see everything. So there is no missing value in this particular data. Okay. Hmm. Now if you want to see some visual representation of your data, you can use matplotlib and you can plot some distribution. So here I'm using histogram, and I'm plotting my data. Okay, the entire data I'm plotting, because if you see, all the columns are numerical. Okay, so that's why I can apply histogram on top of it. So see, if I execute, so this is the representation of the data. It's a multi-class classification. No, it's a not classification. It's a regression problem statement. Bhushan, why regression? Yesterday I told you, because here we have to predict the number between 0 to 10. Okay. Now it can be anything, 0 0.5, 1.5, 1.9, anything it can be. Okay. That's why it's a regression problem statement. Got it? Yeah. Now, can you see the graph, guys? Now, what you can observe from the graph? Anyone, any idea? So those who have already, let's say, worked with statistics, maybe you can answer. So these are the columns. I can say this is a normally distributed column, right? But some of the column you can see it is left squid, right squid, like that. Okay. So you can also handle this kinds of skewness. So there are some power transformer you can apply, or with the help of that you can like fix it. But I'm not going to do it because I told you we'll just try to train the model as soon as possible, and we'll try to build the entire pipeline. Okay. Hmm. Fine. So now what I will do, this is the entire distribution of the data, and this is the target column. Okay. Hmm. Now let's do the trend split. So to perform the trend split, I think you know we can use scale scikit-learn. Inside that we have trend split function. So let's import. And first of all, let's extract my x and y data, because you can see my this is my data. Let's say y dot head. So here these are my independent column, and this is my dependent column. That means these are my x variable and this is y variable. So let's extract them. So here you can see from the intent data, I'm removing the quality and I'm storing inside x variable, because without quality, all of the x variable. Okay. Then I'm also taking the uh, y variable, which is nothing but quality, inside y variable. Yeah. Now I can pass this thing in the trend split function. So here I'm passing x and y. Test size I'm keeping 0.2, that means 80% data I want to keep for my training purpose, and 20% data I want to keep for the testing purpose. And random state here I have given, because let's say if you are using the same random state, so we'll get the same distribution of the data. Okay. So now let's do it. Now if you want to see the shape of each, let's say, distribution, so here is the result. So you can see I'm having 1279 data for the training, 11 column, and testing I got 320 data. Okay, see, this is the entire distribution. Now let's train one model, machine learning model. So now see, in case you can use any kinds of machine learning model, whether you can use linear regression, logistic regression, decision trees regression, you can use random forest regression, you can use. Okay, any kinds of regression model you can use. But I'm going to use one model which is let's say having one amazing functionality called regularization parameter. Do you know about the model, guys? Which model is having regularization parameter in machine learning? Any idea? Let's see who can give the answer. Which data is skew in the graph? So Hushan, you can see there is a skewness in this column. Just a minute. Here is a skewness, alcohol. You can see it's a right skewness. Okay, it is also kinds of skewness. It is also kinds of skewness. Okay, that's how. This is also skewness. For sequential data, always use regression, right? Yeah. So if you have, let's say, normal distributed let's say distribution kinds of, see, these kinds of linear normal distribution, that time you can use this linear model. Okay, alien. Now can anybody tell me the regularization model inside machine learning? What is the name of the regularization model? So have you heard of this model? Anyone? Elastic net sklearn. So this model is having regularization parameter alpha and L1 value. I think you have learned in your machine learning, right? So we'll use this model. You can use any regression model. It's up to you. But let's try to use this elastic net model. So let's initialize the elastic net. So I'm going to call it from the scalar elastic net. This is a linear model, and now let's fit my data. So here I'm setting the alpha value and L1 ratio. You can see this regularization parameter, and here I'm giving my train data as well as the y train data. Now if I execute, now see my model has trained. Now let's try to calculate the accuracy score and losses. So I'm going to import some matrices like mean squared error, mean absolute error, and R2 score. So you already know that in regression problem statement we use these are the matrices. Okay, this is the error and this is the accuracy score. Okay, a mean squared error, mean absolute error, and R2 score. Okay, now let's calculate the accuracy. For this I'm going to create a function. So this function will calculate all the accuracy like your RMSE, root mean squared error, mean absolute error, and R2 score. Okay, so here I'm using all the function, and here this function will take the actual like output as well as the predicted output. Based on that, it will calculate all the metrics. So let's do it. So here I'm going to pass my test data. Okay, first of all, I will give the test data to my model, and my model will give me the prediction, and this prediction I will pass as well as my original y test. Now this will return me the metrics. Okay, now let's visualize all of the metrics. So here is the results I got, guys. So here is the RMSC ME score, and this is the R2 score. I got 25%. Okay, now I can say this model is not good. Okay, because there are lots of pre-processing can be applied, but as of now let's consider we have trained one model and this is the metrics we are getting from the model. Now we'll try to see how we can convert it to the pipeline. Okay, can you do end-to-end agentic chatbot like this with MLOps? Yeah, maybe in future we can do. Hmm. Can you explain what is skewness? Skewness means see your data will see like that. This is the concept of statistics, alien. So maybe you have to learn statistics. Skewness means, let's say, uh, you can see here left hand side you have less data, but in middle position you have like more data. Again, right side you have more data, but it is going like very high here. You can see again it is decreasing here. And normal means this side should be equal. Okay, right side, left side should be equal. Okay, but skewness, see, one side would be less, another side would be high. This is called skewness. Okay, so your data is going like that. So let me draw. I think I can take my pen. Just a minute. See, like that, your data is going like that. Okay, this is called skewness, and normal distribution would be like that. Okay, this side and this side would be same, but here this side is less, this side is high. Okay. Okay, fine. So tell me, guys, did you get it? The entire notebook experiment, how we train the model? Let me know. So it seems easy for many people because if you have already learned, I think you know that. Yeah, fine. Now let's try to see how we can convert the entire project as a more modular coding and advanced ML pipeline. Okay, how it can be done. And for this, we are going to use advanced Python programming. We'll be using something called object-oriented programming here. Okay, to write the entire code. So first of all, what I will do, first of all, I'm going to write the first stage, okay? The first stage, which is called data ingestion. See, inside machine learning project, you have some stage. Just try to remember. Let me write down. Yeah. So inside machine learning project, you have some stage. the first stage we call it as a data ingestion. Data ingestion. Okay. So this particular component will ingest the data from any kinds of sources. Let's say we are using database, DB. So this will ingest the data from the database. Now you can use any kinds of database, whether it's a MySQL database, whether it's a MongoDB, Cassandra, anything you can use here. Even you can also ingest the data from the GitHub. Okay, because machine learning data is like very what I can say, it's a very, let's say, simple file. It's a CSV file, right? It's a Excel file, so we can also upload Excel CSV file in the GitHub also. It is also fine. Okay, you can also load the data from the Google Drive. Okay, like that. Even you can also get the data from any API. This is fine. So it depends upon your data sources. Okay, let's say in your company there is a data is present in the database. That time you have to ingest the data from the database. Let's say data is present in the GitHub, you have to get the data from the GitHub. Okay, so in this example I'll show you how to get the data from the GitHub. Okay, in my next project I'll show you how to get the data from the database. Okay, so both I'll try to show you. Now, once I got the data, that means this particular component will download the data from various sources and it will keep inside the artifact folder. Then the next stage, second stage, we usually do called data validation. Okay, validation. Now, what validation works? Why validation is required? Because after ingesting the data, first of all, you have to validate the schema of the data, whether the data you have, let's say, ingested, whether it is matching with your actual data or not. What is my actual data? I think you remember, this is my actual data. Okay, this is my actual data, and in this data these are my these are my schema, these are my features. Okay, how many column we have? 12 column. So you have to do these kinds of verification. Okay, whether it is having 12 column or not, all the columns are matching or not, all the data types are matching or not. This is called validation. So validation is required because what happens sometimes, let's say in the source database or anywhere, data might be changed. Let's say there is a mistake, other let's say data engineer has pushed any other data in the database and your pipeline is working. So definitely it will take that particular updated data, and whenever you are training this model with your pipeline, it will throw you an error. Let's say this column is not recognized. So before training, because training is at the end costly, because you are training, it takes time, it takes computational power, right? So at the end it's a costly task. So before starting the training, first of all do the verification test whether your data is fine or not, then try to start the training. Okay, so this is the second stage we usually perform. Then third stage will do the data transformation. Data transformation. So inside transformation, you do all the feature engineering. Okay. If you want, you can also perform some EDA task, but EDA is not required because EDA we usually do in the notebook. Most of the time, we'll do the feature engineering. Let's say you want to do 10th split. Let's say you want to do some normalization, standardization, outlier remover. Everything you can perform in the data transformation stage. Let's say you have categorical data. Also, if you want to convert it to the numerical one, you can do it in the data transformation stage. Okay. Then you have something called model trainer. Model trainer. So here you will be basically training the model, and it will give you model dot pickle. Okay, even you can also save the model in a job lib form, because we know that machine learning model we can either save in a pickle format, either we can save in a job lib format. Okay, then once training is done, we can do the model evaluation. So model evaluation. Okay, so inside evaluation you will calculate all the metrics like RMSC, RMS C. Okay, then you have R2 score. Okay, then you have mean absolute error. So these are the things we will try to calculate here. Okay, so these 5 steps we usually follow whenever we try to develop any machine learning project. Okay, data ingestion, data validation, data transformation, model trainer, and model evaluation. Okay, there is another stage you can also add, let's say model pusher. If you want to push the model in the S3 bucket, you can also do model pusher. Okay, pusher can be also applied. I'll also tell you how pusher works. Okay, in my previous next project, there will also push the model. Okay, in the S3 bucket, S3 bucket or anywhere you can push the model if you want, if you don't want to lose the model. Okay, you can push it that time. Okay, so I hope guys it is clear. So the end-to-end component: data ingestion, validation, transformation, model trainer, evaluation, and model pusher. Okay. Fine. Now let's try to implement our first component called data ingestion. Okay. So let's try to implement. So see, first of all, I'll show you the notebook, like Jupyter notebook implementation. Then we'll try to convert this Jupyter notebook as a one modular coding. Okay. Because I know that many people are comfortable with Jupyter notebook implementation. So let's try to simplify the things. So here, what I will do, I'll just create a file. Let me just create a file. So I'm going to name it as inside research folder. I'm going to do all the notebook experiment. I'm going to name it as 01 data ingestion.ipynb because it's a notebook file. Let's take some cell. I'll select my kernel from here. So again, I have to do the same thing because I'm inside research folder. First of all, I have to get back to my project working directory. For this, I use this particular code snippet. I think you remember. So let me execute all of them. I can write in one line. I think that would be fine. Then I can do the pwd operation. Now, guys, you can see I'm inside my root working directory. Okay. Yeah. Now, see, first of all, let me give you the workflow. Like, see, there are so many files and folder you can see in this project. So if you open the src folder, you can see there are so many files and folder like component, config, constant, entity, pipeline, utils. Okay, everything. Now there is a question in your mind. I know that here, which file I have to change at the first time, which file I have to change at the last. Okay, because there are so many files, and what is my main, let's say, starting point of writing the code. So this is called actually workflow. First of all, let's try to write the workflow, and by referring the workflow, we'll try to do the coding. So this is the entire workflow. Let me show you. So this is my project workflow. See, this 9 workflow we'll try to follow. First of all, we have to update the config.yaml file. So inside config folder, there is a config.yaml file. Okay. This YAML file at the very first time I have to update. And in this config.yaml file, all the configuration would be there. Like what would be the, let's say, data ingestion directory, what would be the data validation directory, transformation directory. Okay. What is my data URL? So every kinds of, let's say, configuration we'll try to keep inside config.yaml. Then we have to update the schema.yaml. Okay, there is a file we have created called schema.yaml. Inside the schema.yaml, we'll try to keep the schema, like how many column I have, what is the data type of the column, everything we'll try to mention. Then parameters. So here, well, let's say we'll be using elastic net model, and elastic net model is having some parameter like alpha value, L1 ratio. They say later on, if you want to do the hyperparameter tuning, you can also set some parameter, okay, instead of hard code the value. So all the model is having their different parameter, random forest, decision trees, every model is having different parameter. Then we have entity. Okay, what is the entity? Entities means it's a return type of a function. I'll let you know whenever I will write the code, that time you'll get to know. Then configuration manager in src config. So inside src, there is a config folder. Inside that we have configuration.py. So this configuration we have to write. This configuration will provide all the configuration, okay, variable. Let's say you want data ingestion path, it will provide. Let's say you want data validation path, it will provide. Okay, all the path will try to return from the configuration. Then component, that means each component, my data ingestion, data validation, model trainer, model pusher, and so on. Then pipeline, here we'll try to create the pipeline. That means step up execution, because if you see the pipeline, this is called pipeline also. So it will execute like that. Okay, first of all, data ingestion will execute, then data validation, then transformation, then model trainer, model evaluation, model pusher. So model pusher, as of now, we are not going to execute because we'll be using it in my next implementation. That means it's a step up execution. So after running data ingestion, you can't run model trainer, because first of all you have to validate the data, transform the data, train the model, then model pusher. So it's a step up execution, and this is called pipeline, and this pipeline we'll try to mention here. Okay, then we have main.py, which is nothing but my endpoint. Okay, and we have app.py, which is nothing but my application. That means whatever Flask web application we'll try to create, will create inside app.py. Okay, so this is the entire workflow of my project. I hope you clear, right? Now let's write one by one and try to see how it can be done. So for this, first of all, let's write the config.yaml file. So I'll open up the config.yaml file, and inside that, I'm going to mention my data ingestion related configuration. So this is what my data ingestion configuration. Okay, see. So here I have mentioned my artifact directory. That means I told you that it will create an artifact folder. Inside that, it will ingest the data, validate the data, train the model, evaluate the model. Okay, all the generated file it will save in the artifact folder. That's why this is my artifact root. Now this is my data ingestion related configuration. So first of all, I'm mentioning my data ingestion folder inside artifact. Then this is my source URL of my data. So I have uploaded my data inside my GitHub, guys. This is my GitHub URL. How to upload? I'll let you know. So let's say this is your GitHub account. So let's search any dummy repository. I have one repository called branching tutorial. Let's open it up. So inside that, you can upload any kinds of data. How to upload? So here you can do the drag and drop operation. So here, let's say this is the data. So if you want to upload, just do the drag and drop operation like that. Okay. So see, now it is uploading the data. After that, just click on the commit button. Okay, it will try to commit the data. For me, I already have the like uploaded data in my GitHub. So let me show you this wine quality data. So here is the wine quality data. Okay, this is the wine quality data. Now here, what I did, I uploaded the zip file. You can see I make a zip file of this file and I uploaded it here. Now click on the view raw. It will start downloading. Otherwise, what you can do, you can click here and right click and copy the link address. Okay, and here is the data URL. Okay, this is my complete data URL, and this URL you have to mention here. Okay, here you have to mention. Now let me share you the zip file as well. So the zip file I have downloaded, you can upload in your GitHub. Okay, quickly. So this is the zip file. And you already have the data, you can also make the zip. Okay, I think you know how to make the zip. Okay, see, just try to see one like component. Rest of the component you will automatically get. Okay, because we'll follow the same approach for all the component. Okay, try to see one component carefully. Okay, so now let's right now see, I have local direct data file and unzip directory. That means what happens, it will download a zip file. Okay, and this zip file I'll save as a data.zip inside data ingestion folder, and this is the path. Then after that, I will also do the unzip operation, and it will save the unzip file inside data ingestion folder. Okay, this is why I have defined all the path. Now see, this path you can also hard code inside the component. But instead of doing the hard coding, I'm writing inside config.yaml file. Let's say later on I want to change anything. Let's say I want to change this URL. What I will do, I will open the config.yaml, and here I will only change. And rest of the code will automatically update. So I don't need to open the code, and manually I don't need to update everywhere. Okay, so this is called code modularity. Always you have to write as a template so that it should be changeable anytime. Okay, anything, any path you can define here. Only you just need to change the configuration file. All the file will automatically update. Okay, that's why whatever variable you feel like this should be changeable later on, you can keep inside config.yaml file. Okay, this is the main advantage. So after execution, you will get okay how things are working. Okay, first of all, let me complete the implementation. Yeah, so this file is updated. Now let's update the second file, schema.yaml and params.yaml. Okay, so here you can see I have schema.yaml. So inside schema, let's mention my data schema. So here, this is my data schema I already prepared. Okay, so guys, I think you know what is the data schema. So you have all the columns, right? I think 12 columns you have. All the column name, fixed acidity, volatile acidity, citric acid. How you will get from the experiment file, you can get, see here, all the column name. Okay, even with the data type also. So this thing you have to mention in the schema at the end. Okay, you can see that. So float, 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 and so on. And we have also mentioned the target column, which is nothing but my quality. This is called schema of your data. This schema will try to match. Okay, whenever we do the data validation, will match this schema with our file. The file will try to ingest from the GitHub. Okay, this is why data validation comes into picture. I hope you got it right. This is what your schema. Now next file will update my params.yaml. Okay, so let's open the params.yaml. So here is my params.yaml. So inside params.yaml, I will update my model parameter. So here also I'm going to use the elasticnet model, because you can see I'm using elasticnet model here. Okay, and this model having some parameter like alpha L1 ratio. This parameter will mention in the params.yaml. So let's do it. So params, I'll mention my elasticnet model. Okay, see I alpha value and L1 ratio. So let's say later on you want to change the value, only open the params.yaml and change the value here. It will reflect inside the code. So no need to hard code the value, guys. This is my suggestion to all of you. Don't hard code the value anywhere. Try to keep any configuration file, and there you just need to keep it. Now you can ask me, why YAML file? Can I use JSON file? Yes, you can also use JSON file to manage the configuration, but YAML is like very well structured format. Okay, so here managing configuration is very easy. Okay, see, like that you can mention, it's a clean way to mention. And most of the configuration file nowadays use YAML file, okay, instead of using Excel or any other file. Sorry, instead of using JSON or any other file. Okay. Hmm. So making sense, guys? Let me know. So first of all, let's complete one stage, then I think rest of the stage would be clear. So first of all, let me complete, then we'll update my entity. So let's write the entity in the notebook file. So this is my entity. So here, let me show you. Mm, This is going to be my entity, data ingestion entity. Now here I'm using data class. Okay, so there is a package called data class. I'm importing data class, and I'm also using path. Why path? Because I think you already know. Because you can see this variable type should be the path type. Okay, because why? If I open my config.yaml, root directory is a path. Source URL is a let me see. Source URL is a string. I'm not defining as a path. Then I have local data file, it's a path, and unzip file, it's a path. And again I'm giving the forward slash, and if you're running in the Windows machine, so there might be possibility it will throw you error. That's why we are handling this scenario with the path library. Okay, yesterday I already showed you one example. Now this entity will return, okay, entity will return all the variable you have defined in the config.yaml. So here I've defined 4 variable: root directory, source URL, local data zip file, unzip directory. So this is what we are returning: local source, then local data file, unzip directory. And here we are specifying the format. Okay, we are specifying the format, what kinds of variable it is. And here we are giving the data class. Why data class? Because see, we have written a Python class. Okay, and I think you know, whenever we write any Python class, inside that if I want to define any let's say class variable, how we can define like that. We just write one constructor. Inside the constructor we can define like that: self dot, let's say name is equal to Bappy. Okay, and self dot email is equal to, let's say, my email. So we write the self here. Okay, but if you're using data class, okay, data class, if you are using this particular decorator, so here you don't need to use the constructor and you don't need to use the self. Okay, without writing this self, you can automatically create the variable inside that. Okay, this is called data class. Okay, I hope you got it. So this is how actually we do the configuration management, okay, in Python. So this is the difference between your actual class and this data class. Make sense? Any way to automate the schema for the columns? No, schema you always need to manually define. Okay, because as a data scientist, after doing the EDA on the Jupyter notebook, you know about the data, how many columns you have, what is the data type of the columns. Okay, so this thing you have to write manually here. So you can't automate this part, right? See, it's just a one time effort, guys. One time you just need to do some effort. One time you just need to do some analysis. Rest of the pipeline will automatically execute. Okay, it's just a one time setup, everything. So second time, whenever you are retaining the model, you don't need to do that. Fine. That's why writing code in Jupyter Notebook, it's easy. But whenever it comes to end-to-end implementation, people face difficulties. Okay. Yeah, so I mean, class would be also on live on YouTube. Okay, same. And guys, if you want to join the course, all the upcoming course, live course, okay, whatever is going on, you can take the Euron Plus subscription, all of you. Okay, so it's only 2,999 rupees. 1 year you can access everything from the Euron side. Okay, any kinds of course, whether it's a recording course, live course, okay, self-paced course, even webinar project, okay, everything you can access in the single subscription. But if you're taking individual course, you have to pay $24. Okay, so my suggestion would be take the Euron Plus, all of you. So let me share the Euron Plus link. Hmm. Okay, and I think agentic AI is also going to start from 15 January. Computer vision has already started, and some course is also coming. You can see the entire upcoming courses. You can click here, Euron courses. So here you will see all the upcoming courses and ongoing courses, everything will be available. Okay. Hmm. Fine. So now what I will do, I will get back. Okay. So guys, this is what we have defined the entity. This is called entity, and this is the return type of a function. That means whenever we'll create the configuration function, so this should be the return type of the function. Okay, I'll tell you okay how to do it. Now let's define the configuration manager, because the next component we have to define the configuration manager. So let's do it. So for this, I need some utility function. So first of all, I'm importing constant. Okay, so constant, so there is a file I have created called constant. Let me show you. This is the constant. Inside that I have one constructor. Let me open it up. This file is empty. First of all, let's define the constant. So this is the constant. See, this constant will return the path of the YAML file. So I have three YAML file: config.yaml, params.yaml, as well as the schema.yaml. Okay, all the YAML file I'm returning the path from here. You can see. Okay, path. So this is the three variable I want to take. Okay, so this thing I can define in the constant, because this path is not going to change. That's why I'm calling as a constant. What is the constant? Constant means it's not changeable. It would be always constant. Okay, that's why this path I have defined in the constant. That means once I have defined the path, it is not going to change. Okay, in my project. Now we can call it from where? From the notebook. How? I can import like that from machine learning project, that means ML project, because it is available in the ML project. Dot constant, that means in the constant folder, I need import everything. Star means I need to import everything. That means whatever, okay, whatever path you have, it will import everything from here. Now we can access all the path. Let's say I want to access this path. I want to access, let's say, config file path. Easily I can do it. I'll call and I'll execute. See, it's working. Config file path is not different because I have to execute this line. Now it will work. See, right? Now see, it is returning the path, and if you press Ctrl and left click, it will redirect to the folder. Okay, yeah, this is called modular coding, guys. Okay, we are creating different module, and we are reutilizing the module inside our development. Okay. Hmm. So now let's delete. Then I also need some utility related function, because I told you we created also utility related function here. So we created read YAML, create directories. Okay. Now I want to read the YAML as well as the create the directories. That's why I'm calling inside that. Okay. Read YAML and create directories from the utility. Okay. Okay. Hi, Bappy. Much love from Nigeria. Thank you, Somto. So we have like so many international learner as well. All right. So now let's try to create my configuration manager. Okay. So let's create the configuration manager. So what I will do. Um, hmm. So this is my configuration manager, guys. Very simple. See, I'm explaining what I have written here. First of all, I have written a Python class called configuration manager. Inside that, I have defined a constructor. Okay, and in the constructor, I am first of all taking all the path, config file path, parents file path, schema file path. From where it is coming? It is coming from the constant because we have imported everything. Then these are the file. Okay, so every company uses modular coding. Yes, Alien. Okay, whenever you are developing end-to-end project like that, you have to use the modular coding with a proper, well organized code. Okay, because there so many developer will be working, so it's required. That's why I'm teaching you this part at the very first time with a simple, let's say, project demo. Because this code, okay, this implementation will use in the other development also, same code that it is there. I'm not going to explain what is constant, what is entity. I'll directly write the code. So that's why I'm explaining everything here. Okay. Okay, so now here you can see I'm reading all the YAML file with the help of read YAML function. The YAML function I have imported here. That is my config, params, schema. Okay, I'm reading one by one. Then I'm creating the directories. What directories? My root directories. What is the root directories? You can see artifact. That means it will create an artifact folder here. Okay, inside artifact, it will ingest my data. Okay, it will create a data ingestion folder. Inside that, it will ingest the data. Now, this is my configuration. Okay, get data ingestion configuration. Now here you can see I have defined the return type of the function, return type of the method. And what is the return type? Data ingestion config. Now I think you remember we created an entity, and this entity should be the return type. Why? Because you can see inside that whatever variable I have defined, only this function is returning those variable only, not else. That's why here I have given frozen is equal to true. That means it will only return these are the variable, not any other variable. If you want to write any other variable, it will give you error because you have already frozen this particular class. Okay, so it will only return this four variable: root directory, source URL, local data file, and unzip directory. Directory, source URL, local data file, and unzip directory. From where I'm getting from the configuration. The configuration we have imported from the YAML file. Okay, now I think you can understand how we have created the configuration, how we have loaded the configuration, and how we are connecting in the configuration manager. Making sense, guys? We have created different module. Now we are interconnecting each other. Now if I call this particular function, I can easily access root directory, source URL, local file, unzip directory, because all the, okay, all the value is there. And here I'm not doing hard coding operation. Here I'm calling from the configuration. Now if I'm changing anything here, it will automatically reflect here also. Okay, I don't need to open this particular file, and here I don't need to change. This is the main use of this particular configuration file and modular coding. Okay, so you don't need to hard code the value. Only one time implementation. Okay, one time effort, everything would be automated. Okay, so that's how we have defined our entire data ingestion configuration. Okay, that means my configuration is ready, and it is returning these are the variable, because in the data ingestion config we have already defined these are the variable. This is called entity. Okay, entity is the, always remember, entity is the return type of a function. Okay, it's a return type of a function. Okay. Hmm. So now let's execute. Okay, it's throwing one error. Data ingestion config is not defined. Okay, data ingestion config is not defined. Okay, so maybe I haven't executed this line. Okay, now it should work. Now it is working fine. So now let's create the next one, which is nothing but my components. That means my data ingestion actual components. That means this component will ingest the data from the GitHub. So let's import some required library for that. So these are the library I need: base, request, okay, zip file, logger, get size, and so on. So with the help of request package, URL request package, I will download the data from this URL, okay, in Python. And with the help of zip file, I'll try to unzip the, like, but unzip the zip file. And logger, I think you know, we have already written the logger, okay, here, custom logger. So it will log the information. And get size means I also want to check the size of the file. Okay, that's why get logger I'm writing. So this is the class I have written, guys. You can see component class. So the class name is data ingestion. Inside that, I have one constructor. It will take the data ingestion config. That means the config you have created, this particular config. Okay. And from there, I have created two methods. One is download file. That means this particular function will download the file from the URL. The URL you have defined. Okay. With the help of this request package. Okay. With the help of request.url retrieve, it will download the data and it will save in the artifact folder and will log the information. Then after that, after downloading it, I have to also extract the zip file because it's a zip file at the end. I also need to extract. How to extract? This is the extract code. Again, it's a simple Python code only. I've written inside a function only. See, first of all, I'm creating the zip file directory and with the help of zip file package and I'm zipping the file. That's it. Okay. Now let's test it whether it's working or not. For this, I'm going to create a pipeline. Let's create the pipeline. Pipeline means it's a step of execution. Okay. Now you can see this is the step of execution. First of all, I'm defining my configuration manager because I need this configuration to pass inside my component. So that's why configuration manager, and I'm getting the data ingestion config. That means this function I'm getting. Okay. After that, I'm initializing my component, which is nothing but data ingestion class, this class, and this class will take data ingestion config. So the config I got, I'm passing inside that. Okay. Then I'm calling my download file at the very first time. That means this function and this function later on. Okay. That means the step of execution. At the very first time, your data should be downloaded. Okay. Then second time, it should extract the zip file. Now you can't do like that. First of all, you are, let's say, calling extract zip file. Then you are calling download file. It won't be working. Okay. First of all, your data has to download. Then you can apply the zip file. And this is what your pipeline is. Okay. Step of execution you are doing. Okay. Now let's execute the code and see. Let's say, see, there is no folder, there is no artifact folder. Now see, if I execute, it will create an artifact folder automatically, but I get one error, request is not defined. Okay, so okay, sorry, I forget to execute this line again. Now let me execute the code. I think it should work. Now see, my data ingestion is completed. Okay, now if I open the artifact, now can you see, guys, inside that it has created a data ingestion folder, and this is the zip file it has downloaded, and after downloading the zip file, it has also done the unzip operation, and this is my CSV data. Okay, and this is what our first component we have written called data ingestion in a notebook experiment. That means if my notebook experiment is working fine now we'll try to convert this code as our modular coding. Now here in the folder we'll try to write. Now I think most of the files are clear, guys. Let me know. Let's say in SRC folder, if you open, now I think you know what is component, constant, entity, pipeline, utils, okay, and so on. Got it, guys? What is component? Component means your actual component data ingestion. Config, configuration manager. Constant, we have already defined. Then entity, return type of a function. Pipeline, step of execution. Utils, most frequent function in the common. Okay, I hope it is clear. And you can see the log folder as well. Inside running log, it has all the log. That means it has started data ingestion, downloaded data, and this is the data size. Okay, everything it has saved in the log file. Okay. Yeah, now let's try to convert this notebook as our modular coding. Very easy. Only we just need to copy paste the code. Okay, how? Again, follow the same workflow. Now see, as of now, we are not writing main.py, app.py. We'll write later on. So let's first of all update the config because config is already updated. I don't need to update. Schema is also updated. Params not also updated. I will skip this part. Now let's update the entity. So what I will do, inside SRC folder, I will open the entity folder. Now config entity. Let's open it up. Now here, what I will do, will open up my notebook, data ingestion notebook, and this is the entity. Let's copy, and inside that I'll paste as it is. That's it. Okay. Then next thing, I will update my configuration manager in src config. So let's open the config folder, configuration.py. So here I'll copy the same code. This is my configuration manager code. I'll paste it here, and this is the entire class. I'll copy and paste it here. Okay, that's it. Now here you have to import this data ingestion config entity from the entity folder. How to import? Just write from ml project dot entity, okay, dot config entity, because you can see inside entity I have config entity, then inside that I have data ingestion config. So let's import it here. Okay, now I think this import will work. Let me see. Okay, so I have to write import. Now see, it's working fine. Okay, this is what we call modular coding. We have written different module. Now you are importing it here. So that's how my configuration manager is ready. The next thing, I have to update the component. So let's open the component folder, and here let's create a file. Create a file. The file name should be data ingestion. Inside component folder, data ingestion file I created. Okay, now copy the data ingestion components. I'll copy the import, paste it here, and the entire class, paste it here. Okay, now again you have to import this data ingestion config. So what I can do, I can import from here. Anything else, I also need the path. Okay, path class. So let's import from path lib, import path. Then anything else I need, I think everything is fine. Okay, yeah, that means my component is also ready. Okay, mm. Now let's see the next one, pipeline. Now let's update the pipeline. So what I will do, I'll go inside pipeline folder, and here I'm going to create a file. So pipeline, I'll name this file as stage 01 data ingestion.py, because data ingestion is my first stage, okay, of the pipeline. That's why I've given stage 01. Now let's define the pipeline. So to define the pipeline, you can follow this code in the notebook. I think remember, we need configuration manager and my component. So let's import all of them. Okay, I imported configuration manager, data ingestion component from the component, and the logger. And here is my pipeline. So here I'll write a class. So stage name is data ingestion stage. Okay, and this is the class data ingestion training pipeline. Inside that I've written a constructor. Inside the constructor, I'm not doing anything. That's why I've given the pass operation. Now inside that, let's write a method. I'll name it as main. Okay, inside that I will copy paste the same pipeline code, this code, and let's mention it here. And everywhere you can see I was using this try except block, okay, to handle the scenario. That means exception scenario. So if I open the data ingestion, see try except block, not here, I think this configuration. So let me mention main. So this is what your pipeline. Okay. You can also give try except block like that if you want. Okay, try except block you can also write. Otherwise, you can also keep it like that, because we already handled this situation in the with the Python box, like, do you remember? Yeah, try except block. So that's why I'm not giving it here. So my pipeline is ready. Now let's write the endpoint main.py. So I'll open the main.py. Inside that, I'm going to call my endpoints. So first of all, let's import my data ingestion pipeline from the pipeline itself. See here I'm importing logger and ML project pipeline. That means from the pipeline state 01 data ingestion, I'm importing this particular class. Okay. Now if you call this method main, that means your execution will start. So that is what we'll try to do now. So inside main, I'll call like that. Okay, stage 01 data ingestion. Inside try exit block, I'm logging. First of all, data ingestion started. Then I'm initializing the class and I'm calling the main function. The main function we have defined here. And if you call the main function, your download will start, then extract zip file will start. Okay. Now see this what we are doing, and again log in the information. Let's say my data ingestion completed. If this is successfully running, and if any exception is occurring, I'm raising the exception here. Okay. Yeah. Now let me save, and now let me show you whether it's working or not. For this, I'm going to remove the artifact folder. Now let's open up my terminal. I'll zoom. Now let's execute my endpoint main.py. So Python main.py. Now see it's running. Now data ingestion complete. Now if you go to the artifact, see data zip file and unzip file is available. That means it's working fine without any error. Okay, so that's how we do the development, guys. Okay, first of all, do the notebook experiment. If notebook is working, convert it to the modular coding. Very simple. Now let me give you the code. So it is also pushing my artifact, but I don't want to push this artifact folder. So if you don't want to push, you can keep in the .git ignore. So here you can mention I don't want to push the artifact folder. Artifacts. Okay, I think this is artifacts. Yeah, artifact slash star. That means everything I want to ignore. Now see, there is no data. Now I can upload data ingestion added. And now if I go to my GitHub, refresh, see data ingestion has been added. Okay, now you can pull the changes and you can execute in your system, guys, all of you. So the same way we'll try to complete my next component. That means data validation, transformation, then trainer, evaluation, pusher. Pusher I'm not going to do because this is not required pusher. Same way, the same structure we'll try to follow. Okay. So that's why I'll go a little bit faster now. So let's create a file again in the research folder. I'll name it as data validation. Excel, select the kernel, and first of all redirect to the root folder with the help of this code snippet. Let me remove these are the things, just a minute. Okay. So guys, the first thing we have to update, I think remember, config.yaml. So let's open the config.yaml and now mention the data validation related config. This is my data validation related config. So here it will create a data validation folder. Then it will take that data, and this is the data URL. I think remember inside artifact data ingestion, I have wine quality.red CSV. This is my data location, because if I want to verify the data, first of all I have to load the data. And what is the data? This is my data location. And after verifying, I also need to give this status whether my data is fine or not. If fine, I will give true. Otherwise, I will give false. Okay, this is the status file I will create. Inside that, I will write this status. Okay, status file. So this is my config.yaml. Now let's write the schema. I don't need because schema I already prepared. Is this schema I already prepared? Okay, parameters I also don't need because parameters is also ready. Now let's write the entity. So here I will write the entity. But before that, let's load the data. Pandas. Then I will load my data. This is my data. Okay, and you can see these are the column I have. Okay, now I'll do the compare with my schema. So let's define the entity. So this is the entity. Again, I've written a data class. Inside that, I'm returning these are the variable only: root directory, unzip, status file. Root directory, status file, unzip, and all the schema. Why all schema? Because I will load also this schema file, okay, and it will give me all the schema, and this one, this is what I will store here, okay. That's why all the schema. And you can see by default your YAML file will return the output as a dictionary. I think I already showed you in the trials, I think you remember, dictionary representation. That's why it's a dictionary type variable, okay. That's it. Now let me define it. Now next thing, I'll write my configuration manager. So let's import some utility, create directories and read YAML, and this is my configuration manager. Now same configuration manager class, I'm reading, taking the file path, reading the YAML file, creating the root directory, and here is the function get data validation config. Previous one was get data ingestion config, now it is get data validation config, and this is the return type. So the return type we have defined here, okay. Now it will only return, these are the variable root directory, status file, data unzip, and all schema. See, all schema. From where I'm getting, getting from here, because here we are reading the all the configuration. That means my root directory, status file, and config, and schema. Schema I'm reading from here. I think remember schema we are reading. Okay. So this will return all the configuration. Now let's execute. Now next thing, we'll try to update the component. So let's write the component. So I'll import some library, and this is my component. And again, it's a very simple Python code. See. So it's a class data validation. Inside that one constructor, it will take the data validation config, and it will validate all the column. Now see here what I am doing. First of all, I'm reading the data. Okay, I'm reading the data. That means the actual data, this data. Then I'm getting all the column of the data. Okay, I'm getting all the column of the data, and I'm comparing with all the schema. Here is the for loop. In this for loop, I'm comparing. Okay, now here, if, okay, you can see, let me show you validation status. See, for column, see, here I'm telling if column is not in all schema. Okay, if it is not in all schema, that means the column we are reading from here. Okay, if some of the columns are missing in this schema, that means this is not the actual data. There are some issue with the data. Okay, that's why I'm keeping my status as false. That time you can see here, keeping the validation status as false. Okay, otherwise I'm keeping it as true, and I'm updating this file is a status.txt in the artifact folder, and I'm returning the status. That's it. Very simple code. Only we're doing the comparison. All the column I'm reading, and here we are doing the comparison with the schema. That is what we are doing. If you want, you can also compare the data type also, but I haven't done this part because I want you to do it. There is another for loop you can write. So in every for loop, you just also compare the data type, whether it is having float or not, like that. Okay, this is called second layer verification. You can also do. Now let me execute. Right. The next thing, we'll try to do the pipeline. So let's create the pipeline to test whether it's working or not. So this is the pipeline. So defining the configuration manager, getting the data ingestion config, okay, then initializing the data validation component, and inside that passing the configuration, and I'm calling the method validate all column. Okay, now if I execute, you'll see that it will create another folder in the artifact called data validation, and inside that one txt file is there. Now if I open it up, see it's true. But somehow, okay, let's say in some mistake, let's say one schema is not present. So what I will do, I will open the schema. Let's say this alcohol is missing. Okay, now if I again execute, now if I show you the status, it's let me open it up. Okay, so maybe some mistakes are there. Okay, sorry, I'm changing it here, guys. That's why. I'm changing it here, so I don't need to change here. It should be fine. So let's say somehow your column is missing here. Okay, one of the column is missing here. That time it will give you error. Okay. That time, not error, it will give you status is equal to false because your column is not matching. Okay. Hmm. So you can try, maybe you can upload a different CSV file in the GitHub and you can execute. You'll see that status would be false that time. Okay. Yeah, so that's how our data validation works. Now let's try to convert as our modular coding. Again, the same thing. Let's save. First of all, let's update my config. It is updated schema, updated params, updated entity. So let's update the entity config. I'll copy from here this code and I will update here. Okay, then once this is done, I will update the configuration manager. So open the configuration, and here is my configuration manager, but this part is same. Okay, you can see this part is same. This part is same. I don't need to update. I only need to update the method. So after data ingestion, I'll keep data validation. Okay, like that. Again, I have to call the data validation also. Okay. Now anything else I need? I think everything is fine. Okay. Hmm. Now next thing I'll do it for my uh, component. So let's open the component folder. Let's create another file. Data validation.py, and from here I'll copy all of the code. I also need to import data validation. So from ML project dot entity dot config entity import data validation config, and I also need the pandas. So import pandas spd. And then anything else? I think everything is fine. Okay. Now next thing I have to update my pipeline. So let's open the pipeline folder and let's create another file. I'm going to name it as stage 2 data validation because this is the second stage. Okay, that's why. Now let's write the pipeline. This is the pipeline. Importing configuration manager data validation logger. Stage name is data validation. Creating the class, and this is the main function. That means the uh, pipeline we are copying from here. This particular pipeline. Okay, that's it. Now we have to call this thing in the endpoint. Okay. Now let's open my main.py, and here let's try to mention main.py data validation. But I have to import the data validation training pipeline from the pipeline folder. Hmm. Now it's fine. Now let's try to test, okay, whether it's working or not. What I will do, I will again delete the artifact. Now let's execute. The python main.py. The execution done. If I open the artifact, ingestion data has ingested. Data validation status is true. That means everything is working fine. Okay, no error. So I hope guys you are getting right, and please try to rewatch the recording again after the session. I know that in the live session some of the people will get difficulties. Okay, but after the session just try to rewatch the recording, try to pause the video, try to write with me. Things would be clear. Unless and until you are not writing, things would be difficult. Okay. Yes. Only you just need to understand the flow, how to do for ops for LLM app. For this, we can use LLM ops. Okay, Gaurav. So in my this one generative AI syllabus, we already have the LLM ops syllabus. You can use some tool and you can use some platform. Hi Bappy, I've been following your video from long time and I find amazing, but sometimes I find error in my system while working on the project delivered by you. How I can reach out to you? So you can reach out to me. Just try to send a mail. My mail address is bappy@euron.one. Okay. Yeah, if possible, we'll try to connect in the Google Meet and we'll try to fix that. Okay, Aush. Generative AI Masters, Gaurav. Okay, check it out on the Euron platform, which is available. Even after this live, we have the generative AI live. Okay, 2 p.m. IST. Yeah, okay, you are welcome. Okay, so now let's try to complete the second next one also. Data ingestion validation is complete. Now let's do the transformation. Then model evaluation, model trainer, model evaluation. Okay, I'll do quickly because I'll follow the same step. Okay, I'll do the same step. Only the logic will be different. My email is see my this is my email. So Bappy @euron.one. Okay, this one. I'm zooming. You can see. Okay, next one we'll try to develop for the data transformation. So let's do it quickly. So here in the research, I'll create a file called data transformation. Again, let's close. These are the file. And next, first thing what I have to do, I have to get back to my project working directory. Let's copy this code and here let me execute. Okay, done. Now I don't need it. Hmm. So now first thing again follow the same thing config then params entity and so on. So let's update the config. So this is my config. Here I have to update my data transformation related configuration. Okay, so here I will create a transformation folder in the artifact and this is the data path. Okay, here my data is present because uh see the data transformation step here will only do the train test split operation. Okay, only will do the train test split operation because if you see my actual notebook, so here I'm not doing any kinds of feature engineering task. Okay, but if you want to do any feature engineering task, let's say you want to do normalization, outlier removers, okay, missing value handling, everything you can perform in the transformation stage. Okay, whatever things you have learned in the machine learning, whatever things you used to perform in the notebook, same thing you can do here. Okay, but only will do the train test split operation here. That's it. So here let's define the entity. Okay, so root directory and data path only we have root directory and data path. Then next thing I will create my configuration manager. So let's create port the utility. After that, this is my configuration manager class, the same class, only the method is changing, get data transformation config, and again this is the return type. Okay, and it will return only these two variable root directory and data path. Root directory and data path from where? From the configuration itself. Okay, now let me execute. Okay, error I'm getting because I have to execute this line, then it will work. Hmm. Once it is done, then I will also write the component. Okay, let's write the component. So let's import some library. So here we'll only do the test split. That's why I'm importing test split from the scikit-learn. Then this is the class I have written. So here I have written one thing. Note, you can add different data transformation techniques such as scalar, PCA. Okay, you can perform all kinds of EDA in ML cycle here before passing this data to the model. That means here you can pass every kinds of feature engineering task. Okay, I haven't done because I want to show you quickly, because that's why. But if you want, you can also add it. Okay, you can create a different function. Let's say you want to do missing value handling, create a function. Let's say you want to do outlier remover, create a function. Let's say you want to perform PCA, create a function. That's how you can do it. Okay. Now here we are only doing the 10 test split operation. The data we are having, we're doing the 10 test split operation, and we are saving as a CSV file in the artifact folder. That's it. Now let me execute. Now I'll call the pipeline. Now, if I show you my data transformation, see, this is my training data, this is my test data. That's it. Okay. Only I have done the train and test split. So train data I will be using for the training my model, test data I will be using for the evaluate my model. Okay. That's it. Fine. Now let's try to convert as a word modular coding. Okay. So let's convert as our modular coding. So again, what I will do, I will update my entity. So here is my entity. Let's update the data validation will update data transformation. Then I need to update my configuration. So this is the class I'll copy, and here I will update. Okay, and here I need to import this data transformation config from the entity. Now it's fine. Now let's create the component. Now inside that, let's write the component. Okay, so now let's import this data transformation config. So from ml project dot entity config entity, import this transformation. Now anything else I need? No, I think everything is fine. Now what I will do, I'll create the pipeline. And this is my third stage. Okay, so here let's try to mention the pipeline. But one thing I will do inside pipeline, we'll check the status first of all. Okay, why we have to check the status, guys? Can anybody tell me? Because see, I think remember in the data validation we created one status, and if status is true, that means my data is in correct format. There is no issue with the data. Okay, yes or no? So first of all, we'll check if my data is in correct format, then I will try to do the transformation. Otherwise, I will raise the error. So this is what I'm doing. First of all, you can see I'm defining the class, and here is the checking I'm doing. First of all, I'm loading the status.txt file, and I'm extracting the true form here. Okay, true form here I'm extracting with the help of string manipulation, string slicing. Then I'm checking if status is true, then try to perform the transformation. Otherwise, raise the exception. Your data schema is not valid. Okay. So this particular operation you have to perform. This is super important, guys. Okay. Unless and until you are not doing it, don't train the model, because in the production there is a possibility your data may change and you may end up with an error. Okay. So that's why you have to do the validation check always. Okay. So it's done. Now let's add in the endpoint. So main.py. So I'll import the data transformation pipeline from pipeline itself. Then I will add my transformation. Okay. Done. So I'm calling the main function. Now let's test whether it's working or not. I'll again delete the artifact. Now here I'll open python main.py. Should work. See, done. Now if I open the artifact, data ingestion done, validation is also done, transformation is also done. Okay, that means it's working fine. But got it, guys? We only left two more component. Okay, model trainer and evaluation. I think it will take 10 to 20 more minutes. So can I take, guys, 1 to 2 minutes of break and have some water? Because live coding is always fun, and sometimes it's boring also for some people, but it is fun. Okay, because in live coding what happens, uh, we face the error, okay, in real time, and we solve it. But if I'm recording the session, I may cut some part. Okay, that's why I prefer live session a lot whenever we are teaching any kinds of codes and projects. Yeah, hello Prashant. Hmm. So give me 1 minute, guys, I'm coming with some water. Currently, I'm doing your JNAI course. I'm a BC8 second year student. I found your channel yesterday night. Great, Prashant. You can complete that course. It's completely end to end. Okay, so give me just 1 minute. I'm coming. Okay, so guys, I'm back. Okay, so now let's start with our next one, which is nothing but model trainer. Okay, now we'll train the model. So here I can close this tab. Okay, so fine. I'll create a file inside research. Why should we learn generative AI where ChatGPT provide everything? Because see, if you want to work in the industry, you have to implement the product for them. Okay, and it would be generative AI based. So that's why you have to know generative AI. And ChatGPT can't provide everything. Okay, if you ask ChatGPT to implement a software for you, it won't be doing able to do that. And as a human, okay, you can generate good content from the ChatGPT. Yeah, GPT also is Gen AI, na. It's a GPT is a model. Okay, it's a LLM model. Chat GPT is an application on top of the model. Okay, because to get the good performance from the Chat GPT, also people needs to work behind that. That's why. different technologies are coming now. First of all, ChatGPT was different. It used to only give the response. Currently, they have also integrated agents. Now they have also integrated multi agents, agentic AI. Okay, even search engine they have also developed. So without human interaction, how things will work? Tell me. So ChatGPT will save your time. Let's say if you are implementing one project, some of the code you don't need to write from scratch. You can generate the code and you can modify, you can use in your development. Okay, you can debug your code. So it will save your time, but it won't be replacing the software engineering here. Okay, so definitely if you want to survive in today's market, you have to know about generative AI, because all the software is actually using Gen AI concept right now. Okay. Fine. So now let's create the model trainer. So here I will create a file, model trainer, and again let's get back to my root. Okay, now I will create the entity, but before that I have to write the config.yaml. So this is the model trainer configuration. So model trainer folder would be created, and this is my training data path, this is my testing data path inside my artifact. Okay, here inside transformation, this is my path. Okay, I'm defining the path, and after training the model I want to save as a job lib from. Okay, that's why I've given job lib. Save it, and now hmm, define the entity. This is what my entity is. That means my root directory, that test data path. Okay, test data path, train test data path, then model name, then alpha L1 ratio, because I also have the model parameter inside params. Okay, alpha and N1 ratio. That is what I also need to return. And my target column, my which is your target column. It is available in the schema. So here is the schema target column. Okay, quality. So these are the parameter you have to set in the entity. Now let's create the configuration manager. So again the same function, and only this class method is changing. So here I'm returning all of the parameter. Okay, and here from here I'm getting the training elastic net model parameter, then target. Okay, then I'm defining these are the parameter one by one. Now let me execute. Then I will write my component. Let's import some library. So here I'm using elastic net model so that I can train the model. So this is my component. So here I'm loading my data. I'm loading my train data as well as my test data, and after that I'm doing the uh, extraction of X and Y features. Okay, you can see I'm extracting the X feature as well as the Y features, but test data I'm not using as of now, because test data I will be using for the evaluation purpose. Okay, as of now I will only train the model, and here is the model, and I'm giving the alpha value and L1 ratio, random state, and training the model, and after training I'm saving the model as a job lib. So let me do. Now let's execute the pipeline. Okay, now see my model has trained. Now if I show you the model, this is the model. Okay, now let's try to convert as our modular coding. So I'll first of all update the entity. So config entity, from here I can copy, then I'll update my configuration manager. Let's import this trader.config. Mm, everything is fine. Now let's update my component. So here let's create a component, model trainer. Now let's copy. Okay, here I need my model trainer config. So from ml project dot entity dot config entity import this model trainer. Anything else I need? I think no, everything is fine. Now let's create the pipeline as well. So I'll create the pipeline. So I'll go to the pipeline folder. Let's create a file. Name it as stage 04 model trainer.py. Okay. And let's write the pipeline. Okay. So this is my pipeline. Now let's add in the endpoint. So main.py import model trainer pipeline. Okay. Then what I will do, I will initialize my model trainer. Now we can test. So let's delete the artifact. Be done. Now if I open the artifact, data ingestion done, validation done, transformation done, model trainer is also done. Okay, it's working fine. Okay, so now it's done. Now let's try to create the last one, my model evaluation, this one. So again, I'll do quickly. So inside research, I'll create a file called model evaluation. Again, I will get back to my project working directory. Now I'll define my config.yaml. Model evaluation. So here is my test data path. My model path allows the matrix name. Okay, here I'm defining everything. Now let's define the entity. So this is my entity. It will return these are the variable. And now let's create the configuration manager. And this is my final configuration manager. Only this part is changing. So here I'm returning all the variable one by one. Okay. Then after that, let's create the component. Inside component, we'll calculate these are the metrics only. So again, I'll write the same function and save as a results. Okay, now you can see evaluation function, the same function I have written in my experiment.ipynb also. And here I'm talking the test data, predicting, calculating, and whatever score I'm getting, I'm saving as a JSON. And how saving? Because we have also imported this JSON. Okay, save JSON from the utility. Okay, now let me show you. So here I will execute. And now let's call the pipeline. It should work. Now it has saved. Now we can check it out. Artifact, model evaluation, matrix.json, and here is the result. Okay. Now let's try to convert as our modular coding. So I'll open up my entity. Not this one, entity. Yeah. So let's copy the entity. Okay. So after that, I will add my configuration.py. This is what your configuration. After model trainer, I will add the model evaluation configuration, and let's import it as well. Sorry. Hmm. Now anything else I need? I think everything is fine. Now let's create the component. So again, I will go to the component folder, and here let's create a component. Model evaluation. And I'll copy the entire class I have written. Only I just need to import the save JSON as path and this one. Let's import. So from ML project dot entity dot config entity import this one. I need also path. So from path lib. Okay, import path. Then I need save JSON. So from ML project dot utility dot commons import save JSON. Okay, this one. So now let me check. It's fine. Now let's write the pipeline. Okay, so now let's define the pipeline model level version. Yeah, so this is my pipeline. Then I will add in the endpoint. So main.py, main.py. Let's import my model evaluation pipeline. Okay, now let's define the pipeline. Okay, it's done. Now let's test all the pipeline whether it's working or not. I will delete the artifact and let's execute the code. Python main.py. Okay, done. Now if I check, see my trainer has done, even evaluation has executed, and this is the metrics I got. Okay, so yes, everything is working fine. That means all the component we have developed successfully. Okay, got it, guys? Let me know. Now only what you need to do after the class, see the recording and try to write the code along with me. Okay, and execute. Unless and until you are not writing, so things would be clear. Okay, please write the code. Once you write, once you see again, everything would be neat and clear in your mind. And trust me, if you understand one implementation, the rest of the implementation, any kinds of project you can implement in that template. Okay, only the problem statement will change, only the data part will change. Okay, that's it. So let's add quickly this prediction pipeline as well as the user app. So let's quickly create the user app as well, and all the logs you can see it is saving here, all the execution log all of all the stages. Okay, fine. So let's do the prediction pipeline. Okay, so I already told you we'll be using Flask here to create the user app, and Flask we have already installed here. I think somewhere, yeah, we have already installed. So first of all, let's write the prediction pipeline. So here in the pipeline, I'm going to write another file. Now why prediction pipeline is required? Now see, I can train the model. My model training is working. Now let's see if user wants to send some data. Let's say they have one data they want to test whether this wine is good quality or bad quality. So they need to also submit. So for this, I need the prediction pipeline also. So let's create a prediction pipeline, prediction.py. Inside that, this is the prediction pipeline. Okay. So here I'm importing my all the package and I'm loading the model first of all. Where? From the model trainer. I'm loading the model. And here I'm doing the prediction. The user is giving the data, I'm doing the model.predict, I'm returning the prediction. Okay, this part I will show in the user interface. Now let's create the user interface. So here I'll go to the app.py. Okay, now I think Flask code I already explained, like how to create the Flask code. So let's import all the necessary library. So this is the Flask and everything pandas. Then I also imported prediction pipeline from the pipeline itself. Okay, because I need to pass the data. First of all, I will initialize the Flask and render the home page. This is the home page. Okay, for home page I need one index.html which would be available in the template file. Okay, which would be available in the template file. So what I've done, guys, I already prepared one basics HTML and CSS code for you. So let me just quickly paste it here, because again I told you this is not your concern. Okay, HTML, CSS, front end part, any other developer will create. Okay, so I already used ChatGPT and generated one basics template for you. So let me just try to paste it inside that. So I'll open it up. Putting YouTube Office. So here is the static template. Okay, this part I will mention with my project. Not here. Okay, so just a minute. Coding. So I'll remove the HTML template and I will replace with my old one. Okay. Now you can see this is the HTML code. Okay, I have generated with the help of ChatGPT. And again, there is a website called Bootstrap. From there also you can download Bootstrap. Here also you will be getting different template. Okay, you can use them. Only you just need to modify. So I already did it, and this is the result page. Okay, and in the static I have some CSS code. Okay, like style CSS. Okay, these are the things I have in the static. So now let's load the home page and see how my application will look like. So let's initialize my application. So I'm running on the post number localhost and port number 8080. So let's initialize Python app.py. I'll open localhost port number 8080. So this is your application, guys. I hope you can see. Hello, sir. I'm starting to learn ML and deep learning. What the prerequisite and how I can start? First of all, try to complete the Python programming. Okay. So you can check my playlist. So I already have the Python course even on the Euron platform. So you just try to complete the Python, then start with machine learning, then deep learning. Okay, like that. So guys, this is the web application. Okay, wine quality prediction. And here user will get one form, input form. Okay, so inside the input form they will pass the value like fixed acidity, volatile acidity, citric acid, residual sugar. Okay, then they will click on the prediction button and they will get the prediction. Okay, now let's write the prediction functionality. So I'll open up my code and here I will mention another route. Okay, this is the route. So here what I'm doing, I'm taking all the data, whatever data user is passing now, let's say fixed acidity, volatile acidity, citric acid, sugar. So everything I'm extracting from the form with the request.form. See, and I'm storing in a variable. Okay, then I'm creating a list. Inside that I'm giving all the variable one by one by one. Then I'm converting to the numpy array. Okay, then I'm initializing the prediction pipeline. The prediction pipeline we have imported, I think we remember here, prediction pipeline. Okay, then I'm giving the data and it will give the prediction, and this prediction I'm showing in the result.html page. Okay, and if any exception is occurring, I'm raising the exception. Otherwise I'm rendering the index.html page. Okay, this is my prediction part, but user also need to do the training. Okay, how they will do the training? I also need to do another route here. Okay, for training route I've also created another route. You can see this is the training route. So if user is giving slash train, that means it will start the training. And how it will start the training? If you are executing main.py, that means your entire training will start, right? So that's why I'm using os.system commands to execute this command, python main.py, because this is the command we have executed so far. That's why. And then once training is complete, training is successful, it will show. Now let me show you. So I will delete the artifact. So first of all, we'll train the model, then we'll test the model. Okay. So now see, there is no model. First of all, we have to train the model. So I'll come here, I'll refresh. Now to train the model, just give slash train here. Now hit enter. Now see, training successful. Now go back. Now you can do the prediction. Let's say I'll give some value. Then click on the predict. Now see, this is the quality we are getting. So 3.63. That means this is the poor quality of the wine. Okay. Even I've also added my LinkedIn profile, YouTube channel, and GitHub. you can also add. Okay, this is the complete like front end developer like what they will create the front end page for you. Okay, whatever way I created one template for you. Okay, now I think you can see, guys. Now see, after training, this model is again available. Now user can do everything from the user interface, so don't need to go to the coding part. If you want to start the ML now, so there is a course is going on. Let me show you. So full stack data science, okay, by Sudhanshu sir. This one you can start. See, full stack data science. So here ML part will be covered. Okay, MLDL everything. Got it, guys? So this is the entire implementation. Okay, now my application is running fine in my local system. Now next class onward, we'll try to learn how we can deploy as a CI/CD, okay, in the cloud, and we'll try to see how we can add the Dockerization, okay, Docker, to containerize our entire application, and how we can store in the ECR, Elastic Container Registry. So we're not going to use Docker Hub. Going forward, we'll be using ECR. This is the same your Docker Hub. Got it, guys? Now let me push the code so that you can also get it. So completed till evaluation, or let's say app. Okay, done. So now if I refresh, now see everything is available. Now I can also update the readme file. So after running requirement.txt, you have to run app.py. Okay, now let me update. Readme updated. Okay, so now if I refresh, it is available. Okay. Okay, and guys, I created one WhatsApp channel. So if you're interested, you can also connect here. So there you will be getting all the latest update. So this is the link. I'm sharing you in the chat. Okay, this is the WhatsApp channel link. Okay, so now anyone having any query? Otherwise, we can end the session, because this was the entire ML pipeline. Okay, advanced ML pipeline. Now we'll try to see how we can add different MLOps tool. Okay, like ML flow, DBC. Okay, everything we'll try to add. Docker. Any question, anyone? Okay, I think no. Okay, then. So I think we can end the session, guys. This was all. And please try to join the next session. Okay. And after this session, actually 2 p.m. IST, there is another session on generative AI. You can try to join the session also. Okay. So, yeah. Thank you, guys. So bye, everyone. Bye. Thank you.